Okay, so in this tutorial, we're being given our transformation in words, and we need to come up with the new equation. So the information has been given to us in this column. What I'd like to do is to use this column, the replacing column, to come up with a new equation. So I'm going to follow the order that the translations have been given to me. I'm going to start with y equals 3x squared minus 5, because that's my original. And dilated by a factor of 3 from the y. Dilated by 3 from the y. Now I'll show you once. Dilate by a factor of a from the y. We replace x with x on a. I'm going to replace x with x on 3. Therefore, I'm going to have y equals 3. And in wherever x was, I'm going to write x divided by 3 instead, which clean this up gives me 3x squared on 9 minus 5, which is x squared on 3 minus 5. Then translate it up 3. Translate up 3, therefore replace y with y minus 3. So I will have y minus 3 equals x squared on 3 minus 5. Therefore, y equals x squared on 3 minus 2, because the 3 comes over in pluses. And then we go left. Translate left to replace x with x going to left. So plus 2, therefore y equals x plus 2 squared. I might put a third out the front, minus 2, and that's my final answer. Looking at question 2, doing the same things, I've got y equals minus 2x plus 7. That's where we start, that's the original. So I reflect over the x, therefore I replace y with minus y. So I've got minus y equals minus 2x plus 7, therefore y equals 2x minus 7. Translate up 2 units, therefore replace y with y minus 2, therefore the y gets replaced with y minus 2, and that still equals 2x minus 7. The 2 comes over in pluses, so I'm going to have y equals 2x minus 5. Dilated by a factor by a factor of 4. So dilate by a factor of 4 from the x-axis, therefore replace y with y on 4, and that will give me y on 4 equals 3x minus 5, and y equals 2x minus 5, 8x minus 20 as my final answer. And question number 3, I start with y equals 1 on top of x minus 2 squared minus 3. Translate right 1 unit, therefore replace x with x minus 1. So I will have y equals 1 on top of minus 2 squared minus 3. But the x gets replaced with x minus 1. And to clean that up, I've got y equals 1 on top of x minus 3 squared minus 3. Down 2 units. Translate down 2 units. Therefore, replace y with y plus 2. And that will be y plus 2 equals 1 on top of x minus 3 squared minus 3. And when the 2 comes over, y will equal 1 on top of x minus 3 squared minus 5. And then reflect it over both axes. So reflect it over the x, replace y with negative y, reflected over the y, replace x with negative x. So I'm going to have negative y equals 1 on top of x minus 3 squared minus 5. Therefore, y equals negative 1 on top of x minus 3 squared plus 5. And replacing the minus x. So y equals negative 1 on top of minus x minus 3 squared plus 5. I'm just trying to think what's going to happen then. Minus x minus 3 squared is the same as minus 1 times x plus 3 squared, which is minus 1 squared times x plus 3 squared. Minus 1 squared is 1. So that's the same as y equals negative 1 on top of x plus 3 squared plus 5. So we're doing this line by line by line. And the last question, I'm going to start with y equals the sine of 2x all squared. Dilate by a factor of a half from the y-axis. Therefore, replace x with 4x. So it will be y equals the sine of 2 times 4x squared, which will be y equals the sine by half. That's 2. That's 2. That's 2. So that's 2. So that's 4x all squared. Reflect it over the x-axis. To reflect over the x-axis, we replace y with negative y. So I'm going to have negative y equals the sine of 4x squared, which means y equals negative sine of 4x squared. And then translate it up 5 units. Translate up 5 units. Replace y with y minus 5. So my left-hand side will become y minus 5, and my right-hand side will become negative sine of 4x squared, which cleans up, becomes 5 minus the sine of 4x all squared, or alternatively you could lead with the negative 4x all squared and then plus 5. So that's how you do transformations when the transformations have been described to you in words.